get started on today's notes, are there any questions over any of the assignments thus far? Questions on any of the homework assignments? Well, I don't think you've turned anything in since the last time you asked. Yes? Oh, that's right. I can look. Yep. There's no questions on the homework. We're going to go on and get started. Now, the first thing we're looking at is the square root of a negative number property. Now, there's not actually a whole lot to this property. It's just saying if r is a positive real number, then the square root of negative r is I square root of r, whatever r is. And we did this. We did this with 3, 4, 1. We talked about taking the square root of a number. Now, if we take this I square root of r and square it, well, we're going to get back to negative r. What we had before, we took the square root. That's just square root of a negative number property. Now, we're going to use what we learned with I to solve these equations here. And this is going to be the first one that we solve. Now, at this point, we don't normally solve these by factoring because most of them don't always factor well. But we can use the square root method. The square root method will work for these. And when we solve by the square root method, the first thing we need to do is get the term being squared by itself. And the term being squared in this case is x. So the first step to do in getting it by itself is to subtract 4 from both sides. Because our 4 minus 4 becomes 0, leaving us x squared is equal to negative 4. Now at this point here, we need to take the square root of both sides because the x squared, the term being squared, is by itself. And the square root of x squared is x. Is equal to plus or minus, because whenever we take the square root of both sides, we do have to add the plus or minus. And now we need to take the square root of negative 4. Now, when we first went over the square root method, this is one of the problems that we got. We couldn't progress any further. We said it was no real solutions because we could not take the square root of a negative number. Now, since chapter 3.4, we can, because we know the negative part of this radical is going to come out as I. Because I, as we found out the other day, by definition, is the square root of negative 1. So the negative part of this square root comes out as I, leaving us with the square root of 4, which is 2. So the square root of negative 4 is 2i. So our solution for this here is plus or minus 2i. Questions on this here? Any questions over anything we've done so far? Okay. We're looking at another one. And again, we can use the square root method because there is no middle term. All we have to do is get the x squared term by itself. And the first thing we can do is we can add 11 to both sides. Because negative 11 plus 11 is 0, leaving us just our 2x squared is equal to. So we're going to do negative 47 plus 11, which is negative 36. Is our x squared term by itself? No, so what do we need to do? Divide both sides by 2, telling us that x squared is equal to negative 18. What will we need to do next? Square root. Because since we got x squared by itself, we can take the square root of both sides, and our square root of x squared would be is equal to plus or minus. Whenever we take the square root of both sides, we have to put the plus or minus. Now we do need to take the square root of negative 18. Well, the negative will come out as I. Is 18 a perfect square? No. So the easier way to find the square root of 18 is our 30xs calculator. We can say second square root of 18, and it'll tell us that it's 3 square roots of 2. The graphing calculator will turn it into a decimal, but our 30xs will leave it in simplest radical form. So the square root of negative 18 would be 3i square root of 2. In normal form or standard form, we do put the I in front of the radical. We don't put it afterwards. But that is it. There. Questions on any of this here? Questions on anything we've done so far? Are you ready for the next one? Now, this is the last one we're going to do of this type before we move on to the next piece. And this here, f of x equals 4x squared plus 20. If, f of x, find the zeros. If we're finding the zeros, we're trying to see where 4x squared plus 20 is equal to 0. We're finding the zeros. We're trying to see where this is equal to 0. Now we can still use the square root method because we do have a term being squared. We do not have a middle term. So the first thing we want to do is get this equal to 0. And we can do that by subtracting 20 from both sides. Or 20 minus 20 is 0, leaving us with just 4x squared is equal to negative 20. Then what can we do next? Divide by 4 first. Because we want to get the term being squared completely by itself first before we take the square root. So it'll tell us that x squared is equal to negative 5. Now we would square root both sides, telling us x is equal to plus or minus. Because when we take the square root of both sides, we have to put the plus or minus. Now we do need to simplify the square root of negative 5. Well, the negative will come out as I. Can we take the square root of 5? It's not a perfect square. We can plug it into the 30xs and see. It's just the square root of 5. It doesn't reduce in any way. So the solution for this here is just x is equal to plus or minus I square root of 5. Right. If they can't reduce, we just leave it in the radical. Now we could check this. We would have to check it in the graphing calculator. Because we said 4x squared And well, one of the solutions for this is I square root of 5 squared plus 20 equaled 0, yes? We hit enter. This does indeed give us 0. We can say for parentheses, negative I square root of 5, close parentheses, squared, plus 20 is also 0. So we do have two values that will make the function be 0. Questions on this here? And at this point, the square root method is the only method that really works in solving these equations where we have these imaginary, these complex solutions. But this will lead into our first way that works for every possible case. And the first one that we're going to do is this here. Solve x squared minus 16x plus 64 equals 100 using the square roots, or square root kind of method. Now the first step I'm going to do is a little bit interesting. I'm going to factor the left-hand side. Normally we would get it equal to 0, but I'm doing this one a little bit differently just to kind of show something interesting that works out. So if we factor x squared minus 16x plus 64, well, there is no greatest common factor. So the next step after our parentheses is to find the signs. If the third term is positive, our signs are the same and match the sign of the middle term. Since the third term is positive, the signs are the same, match the sign of the middle term, so they will be negative and negative. Factors of the first and third term. Well, factors of x squared are and x. That's the only factors. Now, factors of 64, we have 1 and 64, 2 and 32. 3 does not work, but we do have 4 and 16. 5 does not work, 6 doesn't work, 7 doesn't work, but the last one is 8 and 8. We're going to use 8 and 8, and if we check this, we get negative 8x minus 8x, which is negative 16x, which is the middle term. Questions on any of this so far? So this did factor, yes? But there is something interesting about our two factors. They are the exact same, yes? What's another way we can write something showing that it's being multiplied by itself? Well, I can write this as x minus 8 what? Squared. Well, now we can use the square root method because I do have a term being squared, yes? So at this point, we can actually take the square root of both sides. On the left-hand side, the square root and square would cancel, leaving us with x minus 8 is equal to plus or minus. The square root of 100 is 10. Now, the 3 that we've done today, at this point we were done because x was already by itself. Here, we still have the minus 8 with it. So to solve for x, we would add 8 to both sides, telling us x is equal to 8 plus or minus 10. Any questions on this so far? Can we add 8 and 10 together? No. 8 plus 10? Yeah, you can. Can we subtract 8 and 10? 8, yeah. If we can actually combine them, we need to actually combine them. Because we do have that x is equal to 8 plus 10. And we also have that x is equal to 8 minus 10. Well, what is 8 plus 10? So one of our solutions is that x is equal to 8 minus 10. So the two solutions for this here are 18 and -2. If we can actually add them, we're going to add them. If we can't, I'm going to change it slightly. If it said that it was 8 plus or minus 10i, 8 and 10i are not like terms. So we would leave it as 8 plus or minus 10i. But since we got 8 plus or minus 10, we're going to actually add the 2 and subtract the 2 from each other. Does that make sense? But that's it. Yes. Any questions on this here so far? Now the reason this worked, and the reason that this worked nicely, was because this right here, the x squared minus 16x plus 64, is a special type of quadratic. It's what we call a perfect square trinomial. Perfect square trinomial. And there's two of them. You can either say it's a minus or ax minus b, which is going to be ax squared minus 2abx plus b squared, or ax plus b squared, which is our ax squared plus 2abx plus b squared. So it's a trinomial, a quadratic, that can be turned into a set of parentheses squared. Now, if we're able to do that with every single quadratic, we can turn it into a set of parentheses squared, then we can take the square root of both sides and solve, just like what we did here. That means we could solve any quadratic if we could do that. And that actually is the first method that works for any and all quadratics. We can solve any quadratic by what we call completing the square. And the main component of this is being able to turn any quadratic into a perfect square trinomial. Rewrite it so that we can turn it into a set of parentheses squared. Now the main step to this is finding a C value, a constant term value that would work every single time. So if we can find this C value that will make this a perfect square trinomial, make it into a quadratic that we can turn into a single set of parentheses squared, we can do exactly what we did in the last problem every single time. Now C does have a set formula for it, for this to work. And C is equal to b over 2 squared. So the constant term is equal to the value of b over 2 squared. Now we get this ABC from the standard form of a quadratic, which is ax squared plus bx plus c. And if we're finding it for this problem here, the value of b in this case would be what? It is 14. And it would be positive 14 because we do take the sign in front of the term, because here we're matching it up to our ax squared plus bx plus c. Now the first thing we could do, or will do, is divide. Do what's inside the parentheses first. So 14 divided by 2 is 7. And lastly, 7 squared is 49. So our perfect square trinomial for this here would be x squared plus 14x plus 49. That's our perfect square trinomial. Now it says also then write the expression as the square of binomial, our set of parentheses squared. And this is kind of nice because it'll work out this way every single time, because we'll have our x. Now the number that goes in there with it, the number that goes here, will be the number and sign of what we have inside the parentheses before we square it, before we find out that value of c. And the number inside the parentheses before we squared it is what? Was it positive or negative? So we would put plus 7. If it had been minus 7 before we squared it, we'd plug in minus 7. And that's it. And this here is the key to solving by the completing the square method, the first method that will work every single time. Questions on this here? Let's look at another one. So we want to write each expression as a perfect square trinomial and then find the set of parentheses squared. And again, finding this value c is going to be the same for all of these here, because our c is equal to b over 2 squared. And for number 4, our x squared plus 8x plus c, what is the value of b? What's the value for b in this case? Number 4, 8. Because again, it's matching up to our ax squared plus bx plus c. So it would be 8. Now we can plug parentheses 8 over 2, close parentheses squared into the calculator, let it do it for us. But it's good to do the division of 2 first, because 8 divided by 2 is 4. Now I can plug 4 squared in the calculator, and 4 squared would be 16. Now when we plug it back in, we get that our perfect square trinomial is x squared plus 8x plus 16. Now as our set of parentheses squared, x, it will always just be x. We won't have a number in front of it. And the reason I do not advise plugging the parentheses 8 divided by 2, close parentheses squared in the calculator, is because doing that division of 2, simplifying that, helps us find the second half of this parentheses, or set of parentheses squared. Because the number we have inside the parentheses here before we square it goes in here too. Since we had plus 4, positive 4 before we squared it, our set of parentheses squared will be x plus 4 squared. Questions on this here? So our answer for this first one is our x squared plus 8x plus 16, and it factors to x plus 4 squared. So let's look at this number 5, x squared minus 2x plus c. What is the value of b? Yes, negative 2. Because since it's minus 2x, the value of b is negative 2. A, b, and c do take the signs in front of them. If there's not a sign specifically written in front of the number in front of x squared, it's understood to be positive. Now we will divide these. Negative 2 divided by 2 is negative 1. And negative 1 squared is 1. So our perfect square trinomial would be x squared minus 2x plus 1. And in factored form, we would have our set of parentheses squared. We will have x every single time. The number that goes inside there next to x is whatever we have inside the parentheses before we square it. In this case, it would be minus 1. Questions on this here? Let's look at number 6. X squared minus 9x plus c. Well, our c value is the b over 2 squared. And negative 9 would be our b value, because it's term in front of x. If there is no middle term, then the b value is 0. But if that's the case, we wouldn't need to use completing the square. We can already use the square root method. Will negative 9 divide by 2 nicely? No. If there were ways to reduce it, we would. If we can't, we just leave it alone. Because if it had been, say, negative 3/2 over 2, negative 3/2 was the value of b, we divided by 2, we will simplify it. But negative 9/2, negative 9 over 2, that's as simplified as it gets. It doesn't get any, we can't simplify it any further. So instead of turning it into a decimal, we're going to leave it as negative 9/2. And if we square it, we get 81/4. So our perfect square trinomial in this case is x squared minus 9x plus 81/4. Now, the value of c, when we're doing this here, to find this perfect square trinomial, will always be positive. The value of c that we plug in to get our perfect square trinomial will be always will be positive. The number that goes inside the parentheses with x can be positive or negative. It could be one or the other. And in this case, our number before we squared was negative 9/2. So here we have x minus 9/2 squared. Questions on finding the value of c? Do we see how we get this? Now this is kind of nice because this method, this is the key part to completing the square. But completing the square will work no matter what the solutions are. If they're real solutions, complex, rational, irrational, it will always work. And this is the first method that will always work. Because factoring didn't work if it wasn't factorable. We had irrational square roots as part of our solution, or I. Graphing doesn't work because if it doesn't cross the x-axis, it doesn't have solutions by graphing, or it crosses at irrational numbers, we have to do a lot more work to get it. Square root method works if we have the x squared, the term being squared by itself, or a set of parentheses being squared. Not everything can be rewritten as a set of parentheses squared. However, the square root method is the first one that works every single time. And there's 4 main steps. And we will get to these especially more tomorrow. I want to show you at least one. I think there's one on the next page. Yes. There's 2. We're going to do one of them. You do not have to write these steps down at this point. I would say at this point I would just watch, follow along kind of visually. I wouldn't worry about writing it at this point. That way you can pay attention and kind of see how this works. The first step in this is a equal to 1. Is the number in front of x squared equal to 1? If not, make it so. Step 2, get all the constant terms away from the variables and leave 2 spaces. Essentially, we're getting the constant term by itself and leaving 2 spots. Find the value of c, b over 2 squared and plug it in. Find the perfect square trinomial and solve our set of parentheses squared. So when we look at this first example, x squared minus 10x plus 7 is equal to 0. The first thing we want to do, our first step, is a equal to 1. Number in front of x squared 1. Well, in this case it is. There isn't a number in front of x squared, so it is 1. Our second step is to get the constant terms, the numbers without a variable on one side and the variables on the other, and then leave 2 spaces. We leave 2 spaces because, again, for the perfect or the completing square method to work, we need to be able to write the quadratic as a set of parentheses squared. We need to rewrite it as a perfect square trinomial. First step is getting the term in front of x squared to be 1. Second step is to get the constant terms to the other side. The next step is to find the value of c. Our c is the b over 2 squared. Well, for this problem, the value of b is negative 10. So we have negative 10 over 2 squared. Well, negative 10 does divide by 2, giving us negative 5. And negative 5 squared is 25. So we add it to it, telling us that x squared minus 10x plus 25 is a perfect square trinomial. Which is nice because, as we just saw in the previous problem, we can rewrite this as a set of parentheses squared. We do have our x. And the number that goes with it is the number inside the parentheses before we square it, which is our minus 5. So we're able to write the quadratic as a perfect square trinomial, be able to factor it to a set of parentheses squared, which means we can really use the square root method now. We can take the square to both sides. But to make our perfect square trinomial, we had to add 25 to the left side, right? If we add something to one side, we have to add it to the other. That's why we had the 2 spaces, just as a way to remind ourselves when we put c in, we're putting it on both sides. We're adding it to both sides. Now, negative 7 plus 25 is 18. Now, at this point here, we can take the square root of both sides to solve for x, which will tell us x minus 5 is equal to plus or minus, well, square root of 18. Since it is positive, we can just plug it into the 30xs. It'll do it for us. 3 square roots of 2. So it tells us that x minus 5 is equal to plus or minus 3 square roots of 2. Lastly, in solving for x, we would add 5 to both sides, telling us x is equal to 5 plus or minus 3 square roots of 2. Now that is our final answer because 3 square roots of 2 and 5 are not like terms, so we can't actually add them together or subtract them from each other. Now there are 2 actual answers. We don't actually have to list it out. One of them is x is equal to 5 plus 3 square roots of 2, and the other is x is equal to 5 minus 3 square roots of 2. But we can rewrite it, or we can have it as 1 with the plus or minus in the middle. Questions on this here? Now that's all we're going to do for today. The homework is 3, 5, 11 through 18. 3 and 5, the quadratic that you're given is already a perfect square trinomial. So all you need to do is factor it, get it to one set of parentheses squared, square it both sides, and solve. So kind of like what we did on the first one. If you do have additional questions on it, please let me know. 11 through 18. finding the value of C, plugging it back in, factoring, what we did for those there. You do not have to actually use the square root method particularly to solve any of these here, because we're going to get more into that tomorrow and how that works.